Alright, so I broke the review into a few different videos. That way you don't have to watch the whole one long video to find the part you might want to review. So in this first video, I'm just going to cover using the empirical rule to find probabilities from Module 1. So the first thing we're going to do is just refresh our memory on how the empirical rule works. So this works when we have a normal distribution. And our normal distribution is always centered at the population mean of mu. We then go out up to 3 standard deviations in either direction. So each of these distances between each spot is whatever our population standard deviation happens to be. So this spot will be mu minus a sigma, this will be mu minus 2 sigma, and this will be mu minus 3 sigma. In the other direction, we're just adding the standard deviation up to 3 times as well. And then what this empirical rule taught us was that if I go out this 1 standard deviation in either direction of the mean, I get 68% of my observations. If I go out 2 standard deviations from the mean, we get 95%. And then if we go out 3 standard deviations, we get 99.7%. So then we could take this picture and sort of break up to find out what was inside each of those pieces. So the numbers I'm going to put along the bottom here are exactly the same. So I'm not changing that here at all. And then we're going to start by working inside out. So I'm going to start with where I know my 68% is. All right, so here's my 68%. My picture's probably not on the best to scale here. So if I have these 2 different pieces, and these have to add up to 68%, the fact that my normal distribution is symmetric will tell me that half of that 68% is on either side. So we'll have 34% in that piece and 34% in that piece. Now when I went out my 2 standard deviations, let me first label this again. So this was 68%. If I go out my 2 standard deviations, this should give me 95%. But what I know is I already have 68% of that on my picture. So I only have that difference that I can add to that picture. So if I take that 95% and subtract off that 68%, I'm left with just 27% to add in these 2 pieces. So if I take half of that, which would be 13.5%. That's how much is in these 2 pieces. Now if I do the same thing with my 3rd standard deviation out, right, so this should give me then 99.7%. But again, this time I've already put 95% on my picture, which only leaves me with 4.7% left that I can add to my picture. So half of that 4.7% goes on either side here. So that's going to be 2.35% in each of those pieces. The last part we have to worry about are these 2 little extra tails kind of outside that 3rd standard deviation. And so what I know is my entire picture has to add up to 100%, but now we've already put that 99.7% left on the picture, so I only have 0.3% I can add to either side here. And again, we're going to split up that 0.3%. So there's going to be 0.15% on either side here. And now if I add up everything, I get my 100%. So it's just a refresher of the rule. Now let's apply that to an example to find some probabilities. So here we're looking at trying to predict the gender of a baby based upon the heart rate. So suppose that we know that baby boys' heart rates are normally distributed, so it has that picture, with a mean of 134 and a standard deviation of 11. So I'm giving you your mu and your sigma there. For part A, we're going to find that probability that a baby boy's heart rate is between 123 and 145 beats per minute. So I'm going to draw my picture. My mean is 134. And then I'm going to go up to 3 standard deviations in both directions. My standard deviation is 11. So that's going to be my distance between each of those pieces. So we're just going to subtract 11 each time that we go to the left here, and add it each time we go to the right. Now this one I'm being asked to find between 123 and 145. So if I look at that, now I am 1 standard deviation in either direction of the mean, so that automatically matches to what I know up here from my empirical rule, and I know that's already going to be 68% between those two values. So then here I'd be able to say that 68% of the baby boys have a heart rate between 123 and 145 beats per minute. My next one, I want to find that it's between 101 and 145. So notice I didn't change my setup at all. So my numbers along the bottom aren't going to change. I still have that same mean and my same standard deviation. So none of these numbers along the bottom are changing. But this time we're asked to find between 101 and 145. So this is what we want to find. So there's a couple different ways to approach this. I'm going to show you one way. So what I know, if I go out 1 standard deviation in both directions, I get 68%. And then I know if I go out 3 standard deviations, but in both directions, I get 99.7. And I've already put 68% on my picture. So that left me with 31.7% more that I can add to my picture, but with 2 different spots to put it, so between here and here. So if I divide that by 2, I get 15.85% for each piece here. And then the ones I want are just the ones that are shaded. So if I take that 68 plus my 15.85, I'm going to get 83.85%. But if you remember this picture up here, that's another way of doing it. You could just add the 34 plus that 34 plus the 13.5 plus that 2.35, and you'll get the same number of the 83.85%. So there's more than one way to do these problems sometimes. So this time I would say that 83.85% of baby boys have heart rates between these two values. So between our 101 and 145 beats per minute. For the next one, we're just trying to find that a baby boy's heart rate is above 123. So we're still working with the same problem. So again, my numbers along the bottom aren't going to change. And this time we're trying to find above 123. Alright, so a couple different ways you could approach this problem. So the first way you could do it is break it up this way. Because I know that 50% is in either direction of the mean. And then I know that here, this piece is half of that 68. Or I would get 34% for that. And then I could add those two numbers together to get 84%. That's one way we could do it. Another way we could do this. So again, just another way of thinking about the problem. So still looking for the same thing. Instead, I could break it up and say, well, I know that one standard deviation out in either direction is 68%. My whole picture, again, has to add up to 100%, so that means I have 32% left. Half of it goes here, half of it goes here. So this piece would be 16%, and this piece would be 16%. And this time I could just add the 68 and the 16 together. So notice either way you get that 84%. So then I could say that 84% of baby boys have heart rates between above 123 beats per minute. At this point, you really could kind of, again, pause the video and try the next two on your own before you watch me do it. Alright, so hopefully you've already practiced then, and we'll see if you get the same thing as me. So again, starting with the same picture. This time we're just trying to find above 167. Alright, so I know that 99.7% is from here and here. So that means each of these little tiny pieces has only 0.15%. That's the piece I wanted. So then I could say that 0.15% of baby boys have heart rates above 167 beats per minute. Alright, for the last problem for this example, we're just trying to find probably that a baby boy's heart rate is below 134 beats per minute. Again, same numbers along the bottom. And this time we're just trying to find below. So how much is left here? Well, you could add up those four separate pieces if you remember those numbers. Or again, we could just also remember that the mean, when it's symmetric, also cuts the data in half. So then there's 50% on either side. So this is just going to be a half. So then there's a 50% chance or 50% of baby boys will have heart rates below our 134. Right, so that's all of the example attached to the empirical rule to find probabilities.